Hey guys, how's it going? Nice work on taking on that test today. And let's keep plugging forward with some new stuff here. What we have today is kind of another way of looking at the fundamental theorem of calculus. So just as a reminder, here's the fundamental theorem of calculus. So once again, we have this idea of we're letting capital F be any antiderivative of lowercase f. So we remember the integral then from a to b of f of x dx gives us capital F of b minus capital F of a. So that's an equation that we know. That's what you guys just used on the test today to evaluate definite integrals. We can take this equation and rearrange it just slightly. Okay, and what we can do is this equation kind of gives us a shortcut for evaluating points on an antiderivative, so on capital F. Specifically capital F of B. So if we take this equation that we have, all I'm going to do is add capital F of A to both sides of the equation. And what we get when we do that then is we get F of B to be by itself, and over here we have capital F of A plus the integral from A to B of f of x dx. Okay. So if we want to know a point on an antiderivative equation, we just need another point, right, which will usually be given to us, and we can just add it to the definite integral from that initial condition point to the point that you want, and that will always give us capital F of B. Okay, so let's see if we can figure out, take a look at an example here. Might be easier to see. But again, this F of A is what I call our initial condition. This is our plus. This is our integral. This is not the only way that we can solve these types of problems, but it's one way that we can. I'm going to show you both ways today, but oftentimes initial condition plus is the plus integral is the fastest way to solve it. So let me show you what I mean by this. Okay, so we know capital F is an antiderivative of f of x equals 2x squared plus 1. And what I'm going to tell you then is I'm going to give you an initial condition. So the initial condition for our capital F, our antiderivative, is we know capital F of 0 equals 6. And our goal is we want to find capital F of 3. Okay. So here's what we do when we see this problem. We first off have to identify the function, and we have to identify the antiderivative. The function here is f of x. The antiderivative is capital F. We can see that just by reading the problem, because the problem says capital F is an antiderivative of f of x. And then we have to identify our initial condition. Our initial condition here is that f of 0 equals 6. So I want to take that initial condition, okay, of f of 0, capital F of 0, right? That's this, my initial condition. And I want to add it to the integral. Okay, I'm doing the integral of f of x, okay, and I want to do it from that initial condition, right? This should always match here, to the one that I want, which is 3. And that will have to equal capital F of 3, okay, which is what we want to find. Okay, so we take our initial condition and we add that to the integral from the x value of that initial condition to the x value of the condition that we want. Okay, the initial condition x value must always be down here, even if it's a bigger number. We'll see that something like that later. Okay, and then up here is always the number that we want to find. Okay, and this works because the fundamental theorem of calculus works. So let's start plugging stuff in and solving this thing. First off, I know f of 0 has a value of 6, so I'm just going to replace the f of 0 with 6. It's the initial condition. And it's going to be the integral from 0 to 3 of my function f of x. I know that my function f of x is 2x squared plus 1. And solving that will give me the solution that I need, which is capital F of 3. Okay? Now I know how to solve this, right? Or hopefully we do. That's what we tested on today. I just need to solve this, add 6 to it, and then I'll get my F of 3. Okay? So let's go ahead and, again, I'll just work through solving this definite integral again, just to see it again, to remind us that it's the same thing we've always been doing. So we've got 6 plus, this thing is in ax to the n form, so it's ready to go. I'll put my brackets in. I bump my power and divide by my new power. And then I tack on my x. Once again, anytime you do an antiderivative, just check, is the derivative of 2/3 x cubed plus x really 2x squared plus 1? The answer is yes, it is, so I know I'm doing it right. I'm evaluating this from 0 to 3. Okay. I'm going to keep writing my 6 plus over and over again because I don't want to forget about it. So I got 6 plus. I'm going to plug in 3. So I'm going to get 2/3 of 3 cubed plus 3. Put that in its own parentheses. Minus 2/3 of 0 cubed plus 0. Equals capital F of 3. I can see that that whole second term there, the evaluating at 0, is going to make 0. And now I just have to work out that 2/3 of 3 cubed plus 3. 3 cubed is 27. Again, how I evaluate this part quickly without a calculator is right in my head. I'm thinking about 2/3 times 27 over 1. cross cancel. I'm going to get 18. I'm going to get 18 out of there plus 3. Again, minus 0. 18 plus 3 is 21. 21 plus 6 is 27. So I get 27 equals capital F of 3. So that would be solving the problem using initial condition plus the integral. Okay, so that's one option to solve for capital F of 3. Another option would be to think about an indefinite integral. And that was option 1. Option 2 I can think of in terms of an indefinite integral. I know that f is an antiderivative. Again, just thinking about the same problem. F is an antiderivative of f of x equals, what did I say, 2x squared plus 1. F of 0 equals 6. Find f of 3. One thing I can do here, another option, is I can just find the general antiderivative of lowercase f of x. So one other method I could do here is I could say, well, capital F of x, since it's an antiderivative, must equal the integral of 2x squared plus 1 dx. Notice I don't have any numbers up here. Sorry, that makes it look like zeros. I'm going to erase it. But notice there aren't numbers up there. And again, we also know how to do this because we just did it on our test. Let's erase that. And if I did this indefinite integral, I'd get 2/3 x cubed plus x plus c, right? And the reason I can't solve capital F of 3 without knowing another point on capital F is because that plus c could be anything, okay? That plus c could be anything. So what I'm going to do here is I'm going to say, okay, so that's capital F of x. I'm just going to evaluate that given my initial condition point and solve for c. Again, just to clean it up, I know f of x equals 2/3 x cubed plus x plus c. So now I'm just going to plug in the point f of 0 equals 6. I'm going to solve for c. Figure out what that constant is. So if f of 0 equals 6, right, I'm going to say 6 equals 2/3 0 cubed plus 0 plus c. Again, 2/3 of 0 cubed is 0. 0 plus 0 is 0. 0 plus c is c. And I get 6 equals c. So now I know capital F of x must be, I'm just going to plug this 6 in for the c up here. Capital of f of x must be 2/3 x cubed plus x plus 6. Then I can calculate capital F of 3 to be 2/3 3 cubed plus 3 plus 6. And again, this is 18 plus 3 plus 6, which gives me my answer of 27. So a couple of different ways. You can do an indefinite integral and solve for c by plugging that point in, right? F of 0 then was 6, right? That's my y value. 0 went in for x, okay? But mostly, I think the method that I'm going to primarily use here is initial condition plus integral. There are times later on in the course where we're going to use that solving for c method, okay? But they're both out there. Let me show you the same type of problem, but in a little bit different of a format. Okay, so here's another example. Okay, so this is the same exact setup. We're just using slightly different notation. Instead of having lowercase f be our function and capital F be our antiderivative, we're letting f prime be our function and lowercase f be our antiderivative, right? That should make sense because f prime is always the derivative of f. So f must be the antiderivative of f prime. So it's the same concept here. I have an initial condition, right? My initial condition here is f of 1 equals 5. And I have a function that I'm going to integrate. That function will be 4 over root x. And doing so from 1 to 9, doing that integral from 1 to 9, will give us the value of f of 9 once we add that 5 to it. Okay, so once again, I'm taking my initial condition, and I'm going to skip a step here and just put 5 as my initial condition, plus the integral from the initial condition's x value of 1 to the x value that we want, which is 9, of my function 4 over root x. Okay? Solving this will give me the value of f of 9. Okay, so my initial condition of 5 plus the integral from my initial value of 1 to the value that I want, 9, of my function 4x to the negative half, right, or 4 over root x. That will give me my value of f of 9. Okay, so let's go ahead and calculate this thing out. This thing is ready to go. I'm going to bump it up to a half. 4 divided by a half is 4 times 2, which is 8. 1 to 9. Okay. I know that half power means square root. So I've got 5 plus 8 root 9 minus 8 root 1. Right, again, we plug in the top number first, then we do minus the bottom number plugged in. And again, root 9 is 3. 8 times 3 is 24. Root 1 is 1. 8 times 1 is 8. I'm going to do the parentheses first. 24 minus 8 is 16. So I get f of 9 to equal 21. Okay. Now, once again, I could have done an indefinite integral and had plus c, and then plugged in my point to solve for c. Would be another option for, and then plug in 9 to that function once I have figured out c. But the quickest way to get it here is going to be with probably with our initial condition plus. Let me show you one more very quick example. Okay, so this one, the notation here is similar to example 1. F is an antiderivative of, capital F is an antiderivative of lowercase f of x equals 2x plus 6. What's a little bit different here is my initial condition. If you notice, the x value of my initial condition is a bigger number than the x value that I'm looking for. Okay, and you'll see this from time to time in class and on the AP exam and later on, right? We can still solve this thing. You just have to be very careful about how you set it up to make sure you set it up correctly. Okay, so I'm looking for capital F of 1, and I'm using my initial condition of capital F of 5 equals 7. So to start this problem, I'm going to say 7 plus, right, initial condition plus, my integral then has to go from the x value of my initial condition, which is 5. 5 has to be on the bottom here, to the number that I want, which is 1. Now you may say, hold on, that's backwards, right? But that's the way it has to be to give you the correct answer. So anytime you see this, right, anytime you see a given, your initial condition has an x value that's bigger than the one that you're looking for, just know that your integral then will end up looking backwards, right? And we can fix that or we can not fix it. It's up to us. Okay, I'm going to opt to not fix it. Okay, so just be aware that sometimes when you do this, you're going to set up an integral that may look wrong to you with the bigger number on bottom and the smaller number on top. Okay, but it has to be done that way to be solved correctly. Now, I can go through and solve this thing exactly the way it is right now, or if it bugs you to see the 1 on top and the 5 on the bottom, you can switch those two numbers. But what would you have to do if you switched them? Well, you're going to have to change that plus in front to a minus. Okay? I'm just going to keep it as a plus and solve it out, right? But if you switch it to minus, you just got to be careful when you're doing it to make sure that you're following order of operations, but it'll work out either way. So here's what we got. And again, 1 is on top and 5 is on the bottom. I didn't switch them. I kept this as a plus right here. Then when I plug in, I'm going to get 7 plus. I'm going to plug in 1 first. 1 squared plus 6 times 1 minus 5 squared plus 6 times 5. Okay. Solving it out, solving parentheses first, I've got 7 plus. 1 squared is 1, 1 plus 6 is 7. 5 squared is 25. 25 plus 30 is 55. 7 minus 55 is negative 48. And so 7 minus 48 gives us negative 41 for our value of capital F of 4. Okay. Now, if I would have switched the 1 and the 5, then I would have had, right, let's just think about this really quick. If I would have switched the 1 and the 5, I would have had to make this minus, right? So then I would have, plugging in 5, I would have gotten 55 minus 7, which would have been positive 48. But I still would have had 7 minus 48. I would get the same answer of negative 41. So it's personal preference. If you want to keep it kind of in the odd form that it is, you can. If you want to switch it to the form you're more used to, that's fine. You just got to make sure you change this to a minus to follow all of our integration rules. All right, guys, that's it for today. I'll see you guys tomorrow. Talk to you later. 2 chains. Bye.